Hello again. Today we will talk about thermochemistry with the whole chapter. So it's like a series of videos. So please make sure to watch everything about thermochemistry to allow you to calculate, inshallah, any question in thermochemistry in AP. First of all, thermochemistry is the study of the heat change in chemical reaction. So what is heat? Heat is the transfer of thermal energy between two bodies that are at different temperature. We should know the universe composed from system and surrounding. Here, if we lose heat, the surrounding should be absorb that heat to make the universe stable or quantized. Any energy lost by system must be gained by surrounding. And all of us, we know we have exothermic process and we have endothermic process. What is the difference between exothermic and endothermic? Exothermic is heat given off by system to the surrounding, but the endothermic is heat absorbed by the system from the surrounding. Endo. Right now, let's talk about the first law of thermodynamics. The first law of thermodynamics, which is based on the law of conservation of energy, states that energy can be converted from one form to another but cannot be created or destroyed. So we said delta U for system plus delta U for surrounding equal 0. And the delta U here represented the change in the internal energy. The change in internal energy. So the total change in internal energy is from system and surrounding should be 0. And this is based on the conservation of energy. We know that delta U equal Q plus W, where Q is heat exchange and W is a work. So again, the Q is heat exchange in volume and the W is the work. So we have a good information for sign Q and W. So please note that when work done by system on the surrounding, the sign should be minus. So W, when the work done by here, done by system on the surrounding, the W sign should be 0. But when work on the system by the surrounding, opposite charge, so the work should be positive. But for Q, heat absorbed by the system from surrounding, so in endothermic process should be positive and in endothermic process should be negative. Please make sure about these signs to make calculations. We know the work is equal minus P delta V, where is delta V the change in volume, that's mean V final minus V initial, and the P is pressure. Note that, please. For gas expansion, I will write it. For gas expansion, so the work done by the system delta V, because it's expansion, so V final greater than V initial, so delta V is greater than 0, so minus P delta V, it's a negative quantity. Okay, again, for expansion, the work done by the system, V final greater than V initial, so delta V greater than 0, so minus delta PV quantity, or it's a negative quantity. But for compression, delta V less than 0, because the work done on the system, delta V less than 0, and minus P delta V should be in what? In positive quantity. So let's now solve any problems, or two problems from AP textbook. Let's take this example. A certain gas expand. Please break down the question. Expand in volume from 2 to 6. So this is V initial and this is V final. At a constant temperature, calculate the work W in joule by the gas of expand in two cases, A against a vacuum and B against a constant pressure of 0.1. Let's draw a simple one. So here, in initial, and we draw this one for final. First of all, here the volume is 2 liters, and we have pressure here, P. This pressure, opposing pressure. But final, it will be expand to 6 liters, and this is the pressure. So A, against the vacuum, because the external pressure is 0, the external pressure is 0 to the vacuum, so no work is done on the expansion. So W minus P delta V, and external pressure is 0, P equals 0, so W equal 0 as well. But for B, we have 1.2, the external pressure is 1.2, so the same equation, and we substitute each terms, and please don't forget the minus here, or the negative. So minus 1.2 from question, ATM, times what? Change in volume, 6 minus 2. The final answer is 8 liter dot ATM. And here we should convert our answer to joule, and please remember, 1 liter in dot ATM is equal 101.3 joule. So we will take this answer to convert it to the joule, minus 4.8 times this number 101.3. It's equal what? Minus 4.9 times 10 to the power 2 joule. Right now, let's solve another problem. This question. And all of this question from AP Advantage textbook for chemistry 1 and 2. The work done when a gas is compressed in a cylinder, and we have the joule, the work unit, or the value of work. During this process, there is a heat transfer of 128 joule from a gas to the surrounding. We need to calculate the energy change of, so it's the internal change, that's mean delta U. To calculate the energy change of the gas, we need to know delta U equal Q plus W. This equation shows that work and heat. Work on the compression is positive, and because heat is released of the gas, Q should be negative. So this one should be positive charge and this one should be negative. We will substitute each other. Minus 128 joule plus the work 462, and the final answer is 334 joule. As a result, the energy of gas increases by 334 joule. That's it for this video. Thank you.